Good evening. I'll be teaching substitution in algebra tonight. In this equation here, you have 2y minus 3x equals 11. And in the bottom equation, which is already in the main form, y equals 4x minus 7. What you want to do is, you have this y equals 4x minus 7. And since it's just a plain y, it can equal this y right here. So what you can do is you can do 2, take the 2 from here, you can do 2 times this, 4x minus 7. 2 times 4x minus 7. And that would give you 8x minus 14. So you would put into the equation, in this equation, 8x minus 14 minus 3x equals 11. Now what you can already do is 5x. You can go ahead and get negative 8x minus 3x equals 5x. But then you can also add 14 to both sides. And you get 5x equals 25. Divide both sides by 5. You get x equals 5. And then, since you already have this 5 here, you can go ahead and plug this back in the first original equation, or the regular equation if you need to, or the simpler equation if you need to. So what I would do now is I would do 2y minus 3 times 5, which you get from here. And then you do equals 11. So you would have 2y minus 15, negative 3 minus 5 equals 11. And then you add the 15 to both sides. And then you then get 2y equals 26. Divide both sides by 2. Get y equals 13. So your xy pair would be, your xy pair would be 5, 13. We have an extra problem here that's very, problem number 2 is very similar to number 1. And you can pause the video and take the time to do it if you want to, but we're going to come back to this problem later. Alright, the bottom problem, number 3 here, is kind of different. You can tell that the second equation on the bottom is different than the format of the second equation on the bottom of the first problem right here. So, what we're going to do is, we're going to go ahead and flip this equation around. We're going to take it, we're going to subtract the x on both sides. We're going to get y equals negative 3x plus 7. And we're going to keep this equation here. So what we're going to do, it's the same situation. So y equals negative 3x plus 7. We're going to take the negative 3 from up here times this right here, all this, plus sign, times negative 3x plus 7. We're going to get 9x minus 21. So we got 9x minus 21 back in this equation. 9x minus 21 plus x equals 9. So we can add these two together immediately. 10x. Then we're gonna add 21 to both sides, and we're gonna get 10x equals 30. And divide both sides by 10. We're gonna get x equals 3. Perfect. We've already got the x. And now this is very simple, because what we can do now is we can just take it from this equation. We can take this x right here, put it right here. So we can get negative 3y, or negative y plus 3 equals 9. Minus 3 on both sides. Negative 3y equals 6. Divide both sides by negative 3. Y equals negative 2. There you go. You've got your base pair. Or your regular xy pair. Voila. Next problems. Alright, this problem on the back is different. The outcome is very different, and you will see. So, it looks like it's very similar, but it's very different. So what we're going to do, I know what you're thinking. The y is it's just a plain y up here. This can easily go into it. So we're going to go ahead and do that. 4x, we got our 4x from up here. And then we got the minus 4x from right here, minus 4, which is y, along with the 3, which is also going to come with the y. 4x plus 3. And we're going to equal 3 from up here. And we're going to go ahead and get, these two can already go ahead and cancel out. We're going to cancel those out. But then we've got a 3 equals 3. And so since we got 3 equals 3, this problem results with all real numbers. On to the next problem. This next problem has an extra digit, which you can tell is the difference, but there's more to it. So you can obviously see the x's here. This is clearly going to go here. It's going to substitute into here. So we're going to get the 6y from here, minus the next 6y, and then plus the 4 here. And then this negative 4 is going to go right here. It's going to equal another 4. And I know there's a lot of 4's. So these two are going to automatically cancel out. And then these two are also going to cancel out, which leaves us with 0 equals 4. So this means that this is no solution. Yeah, no solution, since 0 does not equal 4. And there's no variable to equal 4. And also, this last equation is with fractions. So we can go ahead and see that the x is 100% the same. So we're going to take the 1/4 y from up here, and we're going to get plus 5/4 y. And we're going to get, and minus 7, and then we're going to get equals 4. And we're going to add these two together and get 6/4 y. And then we're going to get, and then negative 7 equals negative 4. We're going to go ahead and add 7 to both sides. We're going to get 6/4 y equals 3. And this can also be seen as 1.5 y equals 3. So we divide both sides by 1.5. We're going to go ahead and get y equals, and we got our y equals 2. So now what we're going to do is we're going to take the 2 and we're going to plug it back into the top of the equation. So y, we're going to get plus x equals negative 4. And we're going to do this so that we can get the actual x, get the number of x. So we get 1/2 plus x equals negative 4. And then your negative, or minus 1/2, x equals negative 4 and 1/2, or negative 4.5. And our xy pair will be negative 4.5, comma 2. Alrighty. And we got our y equals 2. So now what we're going to do is we're going to take the 2 and we're going to plug it back into the top of the equation. So y, we're going to get plus x equals negative 4. And we're going to do this so that we can get the actual x, get the number of x. So we get 1/2 plus x equals negative 4. And then your negative, or minus 1/2, x equals negative 4 and 1/2, or negative 4.5. And our xy pair will be negative 4.5, comma 2. Alrighty, and that's our fraction problem.